Hi, hello everyone. This is Monica from final year biomedical engineering. Today I am here to present about a signal processing techniques in ventilator monitoring system. This comes under the human assistive devices. So let's start with the introduction. Actually, a ventilator monitoring system is used to monitor and control the mechanical ventilation for patients who cannot breathe adequately on their own due to respiratory or lung illnesses. Actually, it monitors the respiratory parameters like tidal volume, respiratory rate, and inspiratory and expiratory pressures. So, in this case, the signal processing plays a critical role in filtering, analyzing, and interpreting the data from various sensors and ventilators. So, the key components actually, the ventilator monitoring system uses a various sensors like pressure sensor, flow sensor, volume sensors, and oxygen CO2 sensors. Every sensor used to perform a specific role, especially for the pressure sensor is to measure the airway pressure, and the flow sensor is for monitor inspiratory and expiratory airflow. Then volume sensor is for measure volume of air delivered to the patient, and the O2 CO2 sensor is used to assess the gas exchange between the monitor and the patient. So the type of signals in ventilator system. Actually, the ventilator monitoring system use both analog and digital signals. Actually, analog signals like pressure signals and the digital signals like oxygen saturation signals. These are actually based on the three types like time domain signals, frequency domain signals, and waveform signals. Actually, the time domain signals representing the respiratory waveforms like pressure, flow, and volume over time period, and the frequency domain signal is used to analyze the frequency content of the signal. Every signal have a frequency content, so it is used to detect the abnormal breathing patterns through the frequency contents. And the waveform signals, pressure volume and flow volume loops provide crucial insights into the patient ventilator interactions. And the feature extraction. Actually, the features are identify clinically relevant respiratory features like tidal volume, respiratory rate, peak inspiratory pressure, plateau pressure, and work of breathing. The techniques like peak detection, zero crossing, and integration are used to extract these features. So noise source and challenges. Actually, the ventilator monitoring system is also having some noises and challenges like mechanical noise from valve switchings and motion artifacts from patient movements, electrical interference from pumps and monitors, condensation in tubing affecting flow sensors. So the need for stable real-time filtering for cross loop control. Signal processing techniques. Actually, the ventilator monitoring system is signal processing through three kind of techniques like filtering, noise reduction, and signal amplification. The filtering techniques is done by low pass filters and band pass filters, which is used to remove the high frequency noise and isolate the irrelevant frequency. And the noise reduction techniques like Kalman filtering and adaptive filtering to enhance the signal quality, particularly when the patients are moving or in noisy environments. Then the signal amplification ensures the weak signals and sufficiently amplified for the processings. The filtering techniques are performed by the ventilator monitoring system like low pass filter, especially the Butterworth and Bessel forms, remove high frequency noises from the sensors. And the Kalman filters like optimal estimation of pressure and flow signals especially. Then the LMS adaptive filters are used to idle for the varying noise environments. And the median filter is used to reduce the spike artifacts from the machine. Real-time processing requirement. Maybe the ventilator monitoring system is common for each hospital, and now also it was developed because of the real-time processing requirements. It is must real-time processing because it is operated with low latency for patient safety and efficient algorithms required for embedded processors. The hardware considerations like MCU and DSP constraints, power limits, and sensor sampling rates. Because of critical care management, the real-time processing is must and should required for this ventilator monitoring system. So overall conclusion is signal processing is essential for accurate ventilator monitoring system, and advancement in this mission improve patient safety, comfort, and the effectiveness of human assist devices. So in future direction, the smart ventilators with adaptive closed loop controls or maybe arrived. Thank you for your time.